day, everyone. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Please, before we go into today's exercise, do not forget to like, share, subscribe, and click on notification button so that you can have more of my video. Today, we are taking a topic in physics entitled alternating current circuits. Alternating current circuits. Alternating alternating current circuits. Now, there are two major type of electricity. We have the direct current electricity, then we have what is called alternating current electricity. For direct current, let's say you have this conductor and you supply a current I in this conductor. The current will move in only one direction. This is for direct currents, and these direct currents can be found in sources such that can be received in sources such as the battery and the cell. But there is a particular supply also that we can get in such a way that the current will not be moving in a single direction. The value of the current through this conductor is not going to be in a single direction. The direction of these currents coming will be alternating. So the current will be moving up and down like this. That means the value of the current changes with time. The direction of the current changes with time. So this type of supply is called alternating current supply. Alternating current supply. That means the value of the current changes with time. But here, the value of the current here, here the duration of the current changes with time t. Here, the duration of the current is constant. So, for direct current, the duration of the current flow is constant with time. For alternating current, the duration of the current flow changes with time. Now, we can receive alternating current supply from power stations, and we can also receive it from our generators, electrical generator that we use at home. Now, there are some things I need to clarify concerning alternating current circuits. In the circuits that I want to discuss something. And please take note of this pneumonia. Ice, no, Ellie, the ice man. Now, in this particular mnemonic, this E stand for the voltage, S stand for the inductor, then I stand for the current. Here, this one stand for the current, this one stand for the capacitor, and this one stand for the voltage. So for this type of A line that we have here, we are talking about alternating AC circuits that has an inductor L, and then with this particular voltage. So, in which the alternating current I is flowing. Here, we say that for this particular circuit of inductor L, we say that the current lags the voltage. We say current lags voltage. So what am I trying to say is that for this particular circuit that has L there, this current lags voltage, or we can say voltage is current. Voltage leads current. Now, for this one, what we actually is referring to is we are referring to alternating supply of this voltage to a capacitor. This is a capacitor in this alternating current circuits. So we have current I that is flowing. Here, we are saying that for this particular capacitor that is in this circuit, the current here leads the voltage. We say current I leads voltage V. Or we can say uh, voltage B lags, voltage E. This particular E is also the same thing as the voltage. We can say voltage V lags the current I. Now, what do I mean by all this? I want to show what I mean by leads and lags. before we solve an exercise. What I mean by that is this. If we have a given vertical and horizontal axis and we have the voltage here, then we have, let me say, we have a resistor here. Now, let's say this particular sinusoidal curve stands for the voltage, voltage V. Then for the resistor, we have something of this nature. We can look at for this one is for the resistor. We can look at this thing that, I mean, we are having this parameter, voltage and resistor, we are plotting it against time. We can see that for this peak value of the voltage, Vp, and the peak value of the resistor, let me call it peak value R, let me call this peak voltage, peak value V. They, at a particular instance of time, they have their values reach maximum value at this particular instance of time. In that case, we say both voltage and resistor, they are in phase. Now, if you look at this graph, I see how my voltage like this. Then I have the resistor moving this way. So this graph is for the voltage and the no, sorry, voltage and the capacitor, C and V. If you look at this very well, the particular point here, the value of the voltage is 0 volts, but the value of the capacitor, that's capacitance value, is not 0. So we can say that the capacitor here leads voltage by 90 degree. Now, for this other graph here, we want to have the inductor and the voltage. Let's say this is the voltage here. The inductor, we have its own sinusoidal curve in this manner, like this. If you look at this place, the value of the voltage are positive here, while the value of the inductor is negative. And I want to clarify something. The function that we have here is cosine function. That's cosine function for the capacitor. The function for the voltage is a sine function. So if I want to write this one, generally the sine function is like a sine theta, where a is the maximum value of y. I can write it as y maximum, and the value of sine theta, you know that angular velocity is given as change in angular displacement divided by time. So if you cross multiply, our theta will be omega t. So this thing can be written as sine omega t. And then we know that this omega over this particular angular displacement is also can be written as 2 pi. That's for full cycle angle divided by the period. So we have this one like this. And 2 pi divided by t. This 1 over t is a frequency. So that means 2 pi divided by t, which is this angle theta, can be written as 2 pi f. So in a nutshell, this particular 2 pi f is also omega t. So this theta that I have here can be written as y is equal to a sine. This theta will be omega t. So this expression I have here is for this voltage and the resistor. So for my voltage now, I can have this as V, peak value of the voltage sine omega t. And for the resistor, I can also have for the resistor as my V resistor is equal to V peak value of the resistor, the voltage of that resistor, sine omega t. But when we come to the capacitor, for the capacitor, because the capacitor has a cosine waveform, the V for the capacitor is the peak value of the capacitor, instead of sine, we write it as cos omega t. Then for the inductor, you can see that the capacitor and the inductor, they are in opposite placements on this graph. So this one is in the negative side and this one is the positive side. So that means for the inductor, the voltage will be minus Vp cos omega t. So now, another thing I just want us to also take note of before we solve an exercise under AC circuit is the relationship between resistor, inductor, and capacitor in an AC circuit. So if I have this graph here, my resistor is on the horizontal axis together with the current, while the capacitor is in the positive direction. Yeah. Oh, that's it. Sorry, the capacitive inductance is in the direction here, while the uh, no, this is a inductive reactance is in the direction of positive direction of y-axis, while the capacitive reactance is in the negative direction of the y-axis. So now, if you resolve this vector, this is positive and negative. This will be plus xl minus xc. So I can have it like this. This side will now be xl minus xc. And I want to relate with this r. I will have my r here. Now, from vector addition, if you move like this, we can equally move the same value of xl minus xc in this direction here. So total displacement from this origin, no, when you move like this, you cover r. When you move like this, you cover this particular vector, that is sl minus xc. So I can equally have a resultant that move this way. That resultant we have here is known as the impedance. Z is known as impedance. The angle between this impedance and the resistor, which is pi, this particular angle is called the phase angle. Phase angle. Now, if you look at this phase angle, there are two things I want us to take note of it. I first want to take the cos of that angle, cos of this phase angle. That is adjacent all over hypotenuse. So this particular one, that this expression has a name, is called power factor. Power factor. Now, we can equally get this value of a phase angle using tan theta. So tan of this phase angle is opposite. That is xl minus xc divided opposite over adjacent divided by r. So then another thing I want us to take note of is to use the idea of the Pythagoras theorem. If you look at this right angle triangle, relationship between z, r, and this one is z square is equal to xl minus xc square plus r square. So the z now we give us square root of xl minus xc square plus r square. So that means this impedance, the meaning of this impedance is the opposition to free flow of AC currents in an AC circuit containing either resistor and inductor or resistor and capacitor, or the three of them, resistor, inductor, or capacitor. Now, we also have what is called reactance. So reactance is the opposition to free flow of AC currents containing a pure inductor. So it is called reactance. This one is called reactance. So the same thing is applicable to the capacitor. The opposition that the capacitor offer to the free flow of alternating current is also known as capacitive reactance. Then I want to tell us something. When we have the arrangement of the inductor L, and then I have this resistor R, then I have the capacitor C. It has been found that it is only this component. Anytime this component is there, it will dissipate energy in form of heat. So that means it will dissipate power also, power P. But in case of inductor and capacitor, they do not dissipate. They do not dissipate energy. That means they do not waste energy. Therefore, the value of the power for an AC circuit containing inductor, power will be zero. The same thing for an AC circuit that contains only capacitor, the power is zero. But for AC circuits that contain resistor, the power is given as VI. So please take note of that. So with this background now, we are going to solve an exercise on AC circuits. Please, I will do an exercise concerning what I have demonstrated now in my next video. Please, before we go, do not forget to like, share, also click on notification button so that I can have more of my video. Thank you so much. Have a nice day. Bye.